Hello viewers. So in this particular video we will see how we can calculate this sin x series expansion. So sin x formula is x minus x cube by 3 factorial plus x raised to 5 upon 5 factorial minus x raised to 7 upon 7 factorial plus like this up to x raised to n upon n factorial. So to do this particular summation, we will use C language. So we'll do this in C language. If you notice over here, here the terms are there with alternate signs. Okay, first minus is there, then plus, then again minus, then plus. So for this purpose, we will take one variable. We will call it a sign, and we will initialize by, let's say, 1, or you can initialize by 1 and then later on you can multiply it by -1. So alternatively it can change the sign of this particular variable. We will see through the program. Then what other things are required? See, in this x is the angle, okay, and it is given in terms of radians. So from the user we will ask the angle. Okay, from the user we will ask the angle to be entered, and we will store inside this degree variable. Let's say user will enter 30, so we will store 30 inside this degree variable, and then we will convert this degree to radian. How to convert? Let's say I want to convert this 30 degree into radians. Let's say I am having one x angle in radians, so x will be equal to this 30 multiplied by pi. So here we will not write pi, we will write 3.1416, and we will divide it by 180. So it will going to convert into radian. This angle will become now radian. So we will take this x, we will ask from the user degree, and we will then convert into the radian. So we will be having that angle. Second thing, we will take this n from the user. Okay, so we will declare one variable n. We will ask from the user to enter this n, and up to n we will going to do the expansion, and we will calculate the entire sum. So let's say if the user will enter 5, so we will have only these terms, summation of these terms. If user will enter 7, then up to here we will have the summation. Okay, one more thing to notice over here is there is numerator and the denominator part. So again I'll write this series and I'll explain you. Let's say I'm calculating sin x. So sin x is equal to x. Let's take this one as 1 upon 1 factorial. Okay, then minus x raised to 3 upon 3 factorial plus x raised to 5 upon 5 factorial, and so on, x raised to n upon n factorial. So if you notice here, there is a numerator term and there is a denominator term. So we will declare two variables, numerator and denominator. Of course both will be in float or double. We will create this numerator term, then we will create denominator term, and we will have one more variable, that is term. So will be nothing but term will be nothing but numerator divided by denominator, and plus whatever will be the sign. Let's say if it is -1, so we will multiply by -1. If it is +1, then +1. We will see how we can do, but ultimately our idea is what, to calculate this term, and term will be nothing but numerator by denominator. So first we will create this numerator, then we will create denominator, and then we will make the term itself, and then after that we will going to add into sum variable. Sum we will initialize by 0. Then the moment we will form any one single term, suppose this term we calculated, so we will say sum is equal to sum plus term, like this. So up to n we will do this stuff, and we will calculate all the summation. So if you notice in the numerator, there is a power, and it's an odd series, 1, 3, 5. So we will have, we can use one power function. where we can have this x, and here we can use the power, right? And this will be nothing but x raised to power. Or we can write the code also for this one, because in most turbo and all, this power may not give proper result. Then we will have to write the code to calculate this stuff. Then if we see the below one, it's a factorial. So for every odd number we will have to calculate the factorial, and then for that factorial we will create this denominator term. So all these things I'll going to do, and I'll explain also. Let's see, I'll start my turbo. So this is turbo, I'll start the turbo. So let's write this. I'll start with the hash include stdio dot h, then hash include conio dot h, void main. Okay, so first I'll have the terms. So let's say I'm declaring double this x for a radian angle, the numerator, denominator. Okay, sum I'm declaring as 0, and then I'll need the term variable to make numerator upon denominator. Then integer, I require j. For factorial calculation, I need fact variable, and that's it. We will see if we will need more, then we can add over here. Yeah, one more variable we can have, that is the n to ask from the user, and second one is degree. Now let's write clr ask the user to enter the n value. So enter n. User will enter, we will store this one in n variable. So %d and %n. Now we will ask the user to enter the degree, angle /n, enter the angle in degree. So user will read this and he will going to enter this angle. We will store inside the variable degree. So scanf %d ampersand deg, degree. So we have both the values, this n and the degree. Now what we will do, immediately we will convert that degree into radian. So I'll do what, degree multiplied by pi by 180. So pi is nothing but 3.1416 divided by 180. So I'll write the comment, converting degree to radian. So I converted this. Now what I'll do, I'll write the loop. So for, because I have to do summation up to n, here I'll declare I equal to 1, I less than equal to n, I is equal to I plus 2. Why I am doing I plus 2? Because I is equal to 1, so next time it will increment and I'll be having 3 value, I plus 2. So 1 plus 2, 3. And after that, next time I'll be having 3 plus 2, 5. Because this is an odd series. If you see in the numerator term, there is x raised to 1, then x raised to cube, then x raised to 5. So I should have only the odd numbers. That's why I am doing I equal to I plus 1. Now first thing what I'll do, so here I'll have to make the terms, right? So term will be what, numerator divided by denominator. First I'll calculate factorial for the denominator. So I'll declare fact equal to 1, and I'll apply one loop to calculate this. So fact j equal to 1, j is less than equal to n, not n, I. Why I? Because first time I will be 1. So x raised to 1 divided by 1 factorial. So first time we should calculate 1 ka factorial. Next time I will become 3. So it will calculate 3 ka factorial. That's why my j is less than equal to I. J plus plus fact is equal to fact into j. Remember to initialize this fact is equal to 1 because every time fact should be ready for the new factorial calculation. That's why I have initialized by fact equal to 1 inside this loop, not outside over here. Okay, it's inside this particular loop every time because we are calculating for a new number factorial. So this factorial will be calculated. This will I will use in the denominator. So my denominator will be what? This fact. Denominator is completed. Now let's complete the numerator part. So numerator part is nothing but numerator is equal to power of x, that is angle radian, raised to whatever is the I, that number is there. So I'll write over here I. Now this may not work properly. If it will not give proper answer, then we will write the code to calculate this one because it may overflow and it will not going to give the proper answer over here. So we will write the code for this one. We will check it. Now after this, so numerator is completed. Now I will calculate my term. So term will be equal to, so first term is x, right? So here we are having x raised to 1. This one is numerator is x raised to 1. And here I calculated 1 ka factorial first time because I value is 1. Fact equal to 1. So j equal to 1, j less than equal to 1. Fact will be calculated as 1 into 1. So factorial will be 1. So first term is nothing but my numerator divided by denominator multiplied by sine. Now sine is equal to, if you see over here, sine term I have not taken, so I will take it first, sine variable, and I will initialize by 1. So sine, with sine I have multiplied, sine is the value is 1, so I'll be having numerator by denominator, that is x into 1. So first term is what? X will be there and we will add that x to sum variable. So sum equal to this term. So first term x is added to this particular sum variable. Now I'll change the sign because next time sign value is changing. So sign is equal to sign multiplied by minus 1. So it will going to change the sign. So next time, well, it will calculate 3 factorial because I plus 2. So it will become 3 factorial. At that time here it will calculate x raised to 3 and numerator by denominator, this term will be calculated by multiplying with the sign. So sign term will be what now? Minus 1. So it will become minus x cube by 3 factorial. Then again next time the sign will be multiplied by minus 1. So minus 1 multiplied by minus 1, it will become plus. So next time again it will become plus. Like this it will go on calculating unless until we will reach to up to n condition, and finally in the sum will be having the summation. So we will going to print that printf sum of the series is equal to %f sum. I'll write get ch to get the output. To see the output, it will going to hold the screen. So this is our program. Let's run this. There is one error showing because power function we have used. For this we require to include prototype. So we will go above and here we will include this hash include math dot h. This is the function, this is prototype for header file for that math for power function. So this is our standard input output header file, this is console input output header file, and this is math header file. Okay, now again let's run it. So enter n, let's say 7, enter the degree, so I'll enter 30, and sum of the series is 0.5. So it's showing properly. Okay, let me again run. Enter n, let's say 7, enter the angle in degree, let's say 60.866. So it's showing properly, it's giving the proper output. In case if it is not working properly and it's giving you error, that overflow and all kind of error, then in that case this power function may not be working. So I'll just write the code over here. I'll just comment this part. Okay, if it's not working, so I'll comment here and I'll calculate the numerator by code. So how I can calculate? I'll write the for loop. I'll say j equal to 1, j is less than equal to I, j plus plus, and here I'll say I'll, because whatever is the term, that many number of times it should be multiplied, because x raised to 3 means what? X into x into x I have to calculate. So whatever is the I value, that many times I need to multiply the x value. Okay, x value I have to multiply. So for that I'll do what? X is equal, not x is equal to, I'll say, let's say here num equal to 1, right? Numerator equal to 1. Then I'll say num is equal to num multiplied by x. So first time x will be multiplied by num, so we will be having x inside this numerator. Then again it will be multiplied by x, so we'll be having x square in the numerator. Then again it will be multiplied by x, it will be having x cube. So if I value is 3, x cube will be there in the numerator. This is how we can calculate the numerator by the loop. Okay, and every time it will be initialized, so every time for calculation of the numerator we will be having 1 initially, and then by formula this particular loop we will be able to calculate. Again we will run this program. Let's say 7 degree 60. Okay, we are getting the right answer. So if your code is not working properly, you can write this particular loop. Okay, from here this one num up to this thing, and you can calculate the sine series summation. So this is our sine series summation program.